Here's the next electrical K22 paper problem. Problem number 12, based on analog electronics. So we have a MOSFET biased in saturation. He mentioned for some reason ideal MOSFET. The magnitude of the small signal current gain for a common drain amplifier is, so he mentioned common drain configuration. So you need to imagine a common drain configuration. The magnitude of the small signal current gain for a common drain amplifier. So let me consider a common drain configuration using NMOS. Common drain is basically a source follower. So let me have, this is the drain connected, okay, to the ground. So common drain. So where we apply the input to the gate terminal, we apply. So, but instead of a voltage source, so current gain only he asked for. Okay, so we need to consider a current source for a common drain amplifier. So then output will be taken at the, okay, there will be a small RS, there will be capital RS. This is what exactly the source follower circuit is. So this is capital RS, this is small RS, this is where we take the output. This is for the voltage gain. Okay, we did it only for the voltage amplifier. Okay, so with that we'll fine tune. Okay, so he's focusing on small signal current gain for a common drain amplifier. This is clearly a common drain amplifier. Let me confirm first. So this is Vin, means as per the small signal equivalent, this is 0 and this is Vin, and therefore we are going to get V0 by Vin, the potential division between the two, that is going to be capital RS by capital RS by small rs. So that is closer to 1. Yes, that's a source follower, that's equivalent. Okay, now the current gain means, so what is the current here? It is going to be your IG. What is the current here? This is going to be your ID. So do we have a gate current? Do we have a gate current? So ideal MOSFET, okay, there is no gate current. Gate current is always 0, even in the order of microamps. So the gate current is 0 microamps, but ID will exist. ID is equal to what? ID is equal to Vin divided by what? Small rs plus capital RS. Okay, you can take this as the current IN. You can feel this as the input current IN. So this current can be perceived as IN, and this current can be perceived as what? I0. So you can go for the small signal current gain. So it's going to be I0 by IN, nothing but your channel current divided by your gate current. And since the gate current is 0 and ID is always finite, the answer is better. We can go with infinity. So the best possible answer for this problem is the magnitude of the small signal current gain for a common drain amplifier is infinity. That's the correct answer. Okay, very simple problem for 1 mark.